Hi guys, welcome to another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you're looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today we're going over 8.5. Real-world problems with inequalities. Specifically, we're going to think about different situations that have infinite possible answers, and we're going to think about what could be a possible answer and what could not be a possible answer to different scenarios. So, our first practice problem is Tiana sees the sign shown in a store window. Sale, all t-shirts cost less than $16. We're going to write an inequality to represent the situation. So first we need to think about what do we not know? Well, it says all t-shirts cost less than $16, so we don't really know what the cost is. We just know it's less than $16. So we're going to let capital T be cost of t-shirts. And we're going to determine what the cost could be with an inequality. So let's think about what I want. I want to know the cost of the t-shirts. So the t-shirts cost less than $16. The t-shirts cost, we said, is going to be capital T. Less than is very straightforward. So we're going to use the less than symbol, of course. And then 16, also very straightforward, 16. So we come up with the inequality of T is less than 16. Not very specific, but it gives us guidelines. Essentially, this means the cost of the t-shirt can be anything less than 16. Now let's reason it out a little bit more. What's the greatest possible cost of a t-shirt? Because I'm pretty sure that t-shirts aren't going to cost $1. They're probably going to get as close to that as possible. So, greatest possible means the most it could be. So, let's think about our inequality. It says T is less than 16. So, let's reason this. If the cost must be less than 16, then let's think, what's the most it could be? And apparently I can't spell could. Well, let's think of a little number line real quick. I want the values that are less than 16. So what would be less than 16? Well, right next to 16 would be $15.99. Would $15.99 be a reasonable cost? Absolutely. Why do I not go with 15? Well, money doesn't have to be a whole number. You're not going to sell something for just $15 or $16 or $14 or $13. You can have, pennies and all of that. So we can go right up as close to 16 as possible. So $15.99 would be a reasonable amount of money to pay, and it's as high as you can get before getting to $16. So that's going to be our answer. $15.99 is the greatest possible cost of a t-shirt. All right, next example. A unicorn can travel no more than 3.8 miles from its home, or it will cease to exist. We're going to let M represent the distance in miles between the unicorn and its home. We're going to A, write an inequality to represent this situation. So essentially, I need to figure out how far can it travel before it ceases to exist. So we're going to remember that M is distance, And what is the distance that the unicorn can travel? The distance can be, it says, no more than 3.8 miles. So no more than 3.8 miles. So distance, we're saying, is m. Can be no more than. Let's think about what that means. No more means it can't be more than 3.8, but it's implying that it could be 3.8. So that essentially means it must be less than. Since it can't be more than, it's got to be less than. But it could also be 3.8. It's just saying you can't be more than 3.8. So it can be less than or equal to that number. That's what no more than means. So less than or equal to is a symbol that we're going to use to represent no more than. And then our number is, of course, 3.8. So our inequality to represent this non-existent situation is going to be m is less than or equal to 3.8. The distance has to be smaller than or equal to 3.8. You can't go past it. Otherwise, it ceases to exist. Although I'm not really sure it existed in the first place. Part B. What's the maximum number of miles a unicorn can travel from its home? Well, according to our inequality that we came up with, first we'll recognize that maximum means most. Well, since m can be equal to 3.8, then that means 3.8 is the most. Again, if the distance can be equal to 3.8 and you just can't be more than 3.8, that means the most number of miles that unicorn can travel is 3.8, or poof, it's gone. So our answer is going to be the maximum number of miles the unicorn can travel is 3.8 miles. And that's what our inequality states. No more. All right, one more question about the scenario. Is 3.9 a possible value of m? So remember, m is your distance. It's all the distances that unicorn can travel before it ceases to exist. So for example, m could equal 3.8, or it can be anything less. So we're essentially asking, can it be 3.9? Well, we ask ourselves, is 3.9 less than or equal to 3.8? No, it's not. So our answer is 3.9 cannot be a value of m, since m must be less than or equal to 3.8. And 3.9 is not less than or equal to 3.8, so it just doesn't fit. It would not be a solution to our scenario. That doesn't exist. All right, next example. More than 15 members of a committee must be present to elect a new president. Part A, write an inequality to represent this situation. So let's think. What do I not know? Well, I don't know how many members there are going to be exactly. So that's what we're going to use or decide. We're going to let, let's say, capital M be the number of members. So how many must be there? Well, it says more than 15 must be present. So more than 15 must be present. Let's translate that. Well, more than is very straightforward. You're going to use a greater than symbol because that means more than. And then 15. Notice, well, I don't have anything in front. Well, it's obviously going to be the number of members. So the number of members, M, must be greater than 15. So that's our inequality to represent the situation. M is greater than 15. So M can be anything it wants to be as long as it's greater than 15. Part B. What's the minimum number of committee members that must be present to elect a new president? So minimum means the smallest amount that you can have. So let's go back to our inequality. I want to know the smallest number M could be. So let's think. M must be more than 15. So what's more than 15? Well, 16. If you look at it on a number line, and I want M is greater than 15, the smallest, again, would be 16 right there. Now you might be asking, well, what about like 15.1? Well, you can't have 15.1 people. That would just be disturbing, like unicorns. So 16 is your smallest reasonable answer. So we would have to go with an integer solution, meaning a whole number. We would need to think about appropriateness. So what's the smallest reasonable number M could be? 16. So that's going to be our answer. 16 members must be present. That is the minimum number. Last scenario. The 6th grade is organizing a trip to the trampoline park. At least 75 students must sign up to cover the cost of the bus, or they're not going. A, write an inequality to represent this situation. So what do I not know? I don't really know how many 6th graders are going to go. So we're just going to say let capital G be 6th graders. Okay, so how many 6th graders need to go? The number of 6th graders needs to be at least 75. You need at least 75 of them to go. Now, in our previous lesson that dealt with inequalities, we mentioned that at least meant that number or more. So at least 75 means that number, 75, or more, meaning we would be happy with 75 kids, but we would be even happier if we had more. So 6th graders, again, we're letting capital G represent them. At least means I need that number or more. So that number means it can be equal to, but we wouldn't say no to more, so greater than. And our number, again, is 75. So our inequality is capital G, the number of 6th graders, must be more than or equal to 75 kids. Otherwise, you can't cover the cost of the bus. Part B. What's the least possible number of 6th graders who have to sign up in order to cover the cost of the bus? So let's reason this out. If G, the number of 6th graders, must be more than or equal to 75, well, that means what's the smallest number you could have? Well, 75. If I drew a number line just to show you, let's see, we need 6th graders more than 75 or equal to. So what's the smallest number possible shown according to the number line? Well, 75 right there. We're including it. So that's your smallest amount in order to cover the cost of the bus. So our answer is going to be 75 sixth graders is the least possible number that must sign up. All right. I hope this has helped with understanding situations that you can write inequalities for. If it has not, I hope you can find what you're looking for elsewhere. Y'all have a great day.